Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar. This class is based on HSTR Trigonometry and this will be the part 2 lecture on trigonometry. Please do subscribe to my channel if you are watching this video for the first time, and also I have a Telegram channel. Please do join the Telegram channel for more future updates and more discussions based on teacher recruitment examinations. I will give the link of the Telegram channel in the description. And also, if you like my work, then please do like this video class and share among other teacher recruitment aspirants. Now this is the part 2 lecture, right? So previous class was a part 1 lecture and the link of that class also will be given in the description. So please try to watch that class, preferably before watching this class. Okay. So that class is actually based on Karnataka TET and HSTR, and you will get more clarity in this class if you watch that class. Okay. So try to watch classes in order. Means first try to watch the trigonometry part 1, then come back and watch the trigonometry part 2. Okay. Actually, I will try to finish trigonometry in 2 more classes. Means the present class is part 2, right? In the next class, the part 3 will be the last class for trigonometry. By chance, if it takes a longer time to explain, then maybe I will post fourth part also. Anyway, let us see. Okay. So right now is the second part of HSTR syllabus trigonometry. Okay. So even in the previous class we have discussed basic ratios, identities and standard angles and complementary angles. And in this class also I will give one nice gist about these 4 topics, and I will focus on problems based on these. Okay. Basic ratios, identities, standard angles and complementary angles. In the next class, I will try to focus mainly on heights and distances and problems. And in this class, I will also consider this allied angles also. Okay. So this class will be based on basic ratios, identities, standard angles, complementary angles and allied angles. Okay. So we will discuss all topics, and we will also be discussing important and expected multiple choice questions based on each topic, and at the last we will have one overall list of multiple choice questions. Around I think 15 problems are there. Okay. So total this class will contain more than 20 multiple choice questions, which are very important and expected questions for HSTR 2023. Okay. So we shall start the class. To start with, let us first know what is trigonometry. Trigonometry means, in its name only you can understand that trigono means a triangle. Metry means measurement. Basically, trigonometry is a branch of mathematics which deals with the measurement of angles in a triangle or sides in a triangle, and also it deals with the problems connected with these angles in a triangle. Okay. So the actual or the proper triangle which is related to trigonometry is a right angled triangle. So this type of a triangle deals with the trigonometry. Okay. As students, when we start learning trigonometry, I think we started learning trigonometry in PUC, but nowadays ICSE and CBSE kids, they start learning trigonometry in high school only. So kids wonder, what are the applications of trigonometry? Why do we need trigonometry? See, I'll give you one best example. This is the example. If a painter is painting a wall, what will he do if he want to reach this point? He will make this ladder align like this. Means one angle theta. With some angle theta he will align. If you want to paint here, if he want to paint here, then what he will do? He will move this ladder and he will align in a different manner with this angle theta. Okay, now this is nothing but a right angled triangle, right? So he has dealt with trigonometry here. That's the reason why he is able to change this angle thetas every time to reach one certain height, correct? So in the first situation where here he wanted to paint, it was the height here. Okay, now if he wanted to change the height till here, then what he did? He changed the angle. So what he did? He increased the angle of the ladder to change the height on the wall, correct? I can give you another practical example for application of trigonometry. In the park, children slide, right? So here, if the kid wants to slide properly in a very enjoyable manner, then the slide should have a proper angle with the ground. This is theta. Okay. In case if the slide is having less theta, you think like this, if the angle is very much less, then the child would not enjoy. Or if the slide is little bit steeper like this, then also the child would not enjoy the slide, correct? If the slide is in a proper angle theta with this ladder like this, with this angle theta, and this is the ladder, right? Now this will make you one right angle triangle, right? So even this was making one right angle triangle, right? So this is the application of trigonometry. Okay, so here if the slide becomes very much steeper also, your ladder will, see, if it is like this, your ladder will be like this, the child can climb easily. If the slide is like this, then what will be the ladder? It will be more height, right? And here the angle will also increase, correct? So it will be tough for children to climb the ladder. It will become lengthy, and even this one will become little bit horrific, right, to slide. So here trigonometry plays an important role to decide this angle theta. Okay, already I have discussed about all these basics in part 1 class. Here I am giving you just one quick glance, like a quick recap, then we will proceed towards important problems and identities. Okay, now these are the right angle triangles, wherein you can see that this blue color line, it is the opposite side to this angle theta. Okay, and this green color line is the adjacent side to this angle theta. Because this is a right angle triangle, then this will be the hypotenuse. Okay, now in this situation, what are these trigonometric ratios? Sin theta, it will be the opposite side upon hypotenuse. Means if I give the names to these triangles, let it be some ABC, A, B, C, A, B, C, and A, B and C. Now here sin theta will be equal to, what is the opposite side? It is BC, right? And hypotenuse will be AC. Like that only if you want to consider cos theta, then adjacent side, it will be AB upon the hypotenuse AC. Then for tangent theta or tan theta, it will be this sin theta by cos theta. This you know it, right? Tangent will be equal to sin theta by cos theta. See, if you have attended the previous class, then all these things will be very much clear to you. So here it will be opposite by hypotenuse by adjacent by hypotenuse. The hypotenuse will get cancelled, right? See, I can write it here for you if you want. It will be BC upon AC by AB upon AC. This AC will get cancelled, right? You will have BC upon AB, which is opposite side by adjacent side, which will be BC upon AB. Okay, and also we have cosecant theta, which is a reciprocal of sin theta, and then we have secant theta, which is reciprocal of cos theta, and we have cotangent theta or cot theta, which is reciprocal of tan theta. Okay, so all these are basics and you need to be perfect with all this. So this thing though I have already told you, right, that tan theta is equal to sin theta upon cos theta, and cot theta is a reciprocal of tan theta. That's why cot theta will be equal to cos theta by sin theta. So this one, it is a reciprocal, correct? It is a reciprocal. So if tan theta is sin theta by cos theta, cot theta will be the reciprocal, that is cos theta by sin theta. Okay. Now just with that knowledge about sin theta, cos theta, tan theta, secant theta, cosecant theta and cot theta, you can solve problems. Like for example, this is one problem. They may ask a problem like this, which anybody can solve who is having only so much knowledge about sine, cos and tan. No other identity, no other trigonometric value is needed. Just you need to know what is sine theta, cos theta or tan theta. Only if you know those three things, you can solve a problem like this. Okay. The question is, if 5 tan theta is equal to 4, then value of 5 sin theta minus 3 cos theta upon 5 sin theta plus 2 cos theta is. Now what you can do is, what is given first? Given is 5 tan theta is equal to 4. With this you will have tan theta is equal to 4 upon 5, right? So what is tan theta? We know that it is sin theta by cos theta, right? So this one will be equal to 4 upon 5. Or I can write this in terms of sin theta as 4 upon 5 cos theta. You agree, right? Now what is given? Given is this 5 sin theta minus 3 cos theta by 5 sin theta plus 2 cos theta. So you just substitute value of sin theta in this above equation. Whatever the value of sin theta we are getting, what is it? It is a 4 by 5 cos theta. Just write it down here, 4 by 5 cos theta. Then don't change cos theta. We want the same term in the full entire equation so that we can cancel things. Okay. So I am writing sin theta in terms of cos theta and I am not disturbing cos theta value as it is I am keeping. Okay. Now what will happen? This 5 and 5 will get cancelled. This 5 and 5 will get cancelled. And I will have 4 cos theta minus 3 cos theta upon 4 cos theta plus 2 cos theta. Then I will have 4 minus 3 is 1. So I will have cos theta in the numerator. And 4 plus 2 is 6. I will have 6 cos theta in the denominator. This thetas will get cancelled and I will have 1 by 6. Option B will be the correct answer. See, usually people get scared with the name of trigonometry only because of identities and formulas in the chapter, right? But this example is the best example to explain that every time trigonometry does not deal with formulas, correct? We have solved this problem just with one formula. What is that formula? The formula is tan theta is equal to sin theta by cos theta. Just if you have knowledge about this, you can solve a problem like this. Okay. So the problem which is asked in the examination may look tougher, but if you solve it, you will understand that it does not require any tough formula to solve it. Okay. So just with the simple knowledge also you can solve a problem like this. Now let's talk about the trigonometric identities, which are commonly known as Pythagorean trigonometric identities. Now we call them Pythagorean trigonometric identities because they are derived using the Pythagoras theorem. Because when we talk about a right angle triangle, we talk about the Pythagoras theorem, right? So in this triangle, if I am writing the value of the adjacent side as 1 unit, the value of the opposite side as 1 unit, then what will my hypotenuse value be? We know that the Pythagoras theorem deals with this condition, right? AB square plus BC square will be equal to AC square. I have 1, I will add it. So this will be my AC square, or AC square is equal to 2, means 1 plus 1 will be 2, and AC will be square root of 2. This is your Pythagoras theorem, right? Now with this condition I can prove this identity. Actually I can prove all the identities. Right now I am trying to prove the first identity. See, in this triangle ABC, what is the value of sin theta? Sin theta will be equal to opposite side by hypotenuse. Opposite side is BC and hypotenuse is square root of 2. Correct? Like that only, what is cos theta? It is adjacent side by hypotenuse. Now let us take this first identity, which is sin square theta plus cos square theta. I am taking LHS. I will have to prove that this is equal to 1. I am taking this identity. I am trying to prove this. Okay. So left hand side is sin square theta plus cos square theta. Let me substitute. This is 1 by root 2, right? So it is whole square plus this is also 1 by root 2, right? This is also whole square. So this will give me 1 by 2 plus 1 by 2, or this is equal to 1. This is what this identity says. Like that only you can prove other two identities also. 1 plus tan square theta is equal to secant square theta, and cosecant square theta is equal to 1 plus cot square theta. So these are all very, very important identities. You need to remember all these. Better make a list of all the identities after this class and try to revise them again and again. Okay. Now these three identities, they also lead to few other identities. Totally you will have 6 identities. Because cos square theta plus sin square theta is equal to 1 can also be written like this. It can also be written like this. 1 plus tan square theta is equal to secant square theta can also be written like this or like this. Correct? Or 1 plus cot square theta is equal to cosecant square theta can also be written as this and also like this. Just put things in the left hand side to right hand side and put things in the right hand side to left hand side. You can play around as you wish. Correct? So these are the basic trigonometric identities. Okay? Now let's solve another example. The question is, if sin theta plus cosecant theta is equal to 2, then find the value of sin square theta plus cosecant square theta. Okay, so what you are going to do is, you take the given condition, this thing, sin theta plus cosecant theta is equal to 2, square both sides. If you square both sides, you will have sin theta plus cosecant theta whole square. This will be equal to 2 square. Now here you can apply a plus b whole square formula, which is equal to a square plus b square plus 2ab, right? So that thing you do it here. It will become sin square theta plus cos square theta plus, sorry, not cos, it is cosecant, right? Cosecant square theta plus 2 into sin theta into cosecant theta. In the right hand side you have 4. Okay. Now this thing sin square theta plus cosecant square theta is what is asked. You have to see the question carefully. Okay. Then you make one rough plan so as to how to solve the problem. So I will not disturb this because this is what I have to find, right? And here I have one nice situation. Because cosecant theta is reciprocal of sin theta and I have 4 in the right hand side. My sin theta will get cancelled. Here this thing I will keep as it is because that is what I have to find. Okay. Now what I will do? I'll keep this thing in the left hand side only because that is what I am finding, right? Rest things I will send in the right hand side. This plus 2 will go here. So my answer will become 2. Okay. So in the options you will have something 3, 2, 4, 0. So your correct answer is option B, 2. Okay. See, just with one identity, that a plus b whole square identity, you have solved this problem. And another concept which you needed to remember is sin theta is reciprocal of cosecant theta. Now let's talk about allied angles. Allied angles means they are those angles. If you find the sum or difference between two angles, then you will find that they are either multiples of 90 or multiples of 0. See, to visualize allied angles, no, you just see this coordinate axis. You have this origin O and you have this coordinate axis. Now, who are allied angles means from 0 to 90 degree. This is one angle you think. Now the another angle is 180 degree, which is 2 times 90. Then another angle, if I want to complete it with the third quadrant, it is 3 times 90, which is 270. Another angle which I go and by completing this circle will be 360 degree, and it is 4 times 90. So you can see here that the all angles 90, 180, 270 and 360 are all multiples of 9 or multiples of 0, you can say, because here if I want to reach back to 0, then I will have to multiply this 90 by 0. So I will reach it with 0, correct? So here to complete the fourth quadrant, 90 should be the multiple of 0. These angles are known as allied angles. If I go back with the same circle, if I want to go back, then also the multiple will be 90 only, correct? See, 360, if you want to go back to 270, what you do? 360 minus 90, correct? So you are removing only 90 because these numbers are again multiples of 90 only, okay? Now I'll explain you some more things. Like this is one coordinate axis, x and y axis is there. Here we are drawing lines like this. I am making one angle theta here and I am making a right angled triangle. Okay. Now this is my A, B and C. If I want to see what is sine of this theta, cos of this theta and tan of this theta, whatever I will do is, I will do in the first quadrant only, correct? Now this is my opposite side, this will be my adjacent side and this will be my hypotenuse, right? So whatever the angles I will get, all will be positive because x-axis is positive and y-axis is positive in first quadrant. That only if I do in the second quadrant, like this. If this will be my theta and this will be my 90 degree. So here in this scenario, because I will take a sine theta as a opposite side by hypotenuse, I will have positive because y is positive here, right? Y is positive. So here my sine theta will be positive. Rest cos theta and tan theta, they will be negative because they will deal with the adjacent side and adjacent side is a negative x-axis. Okay, I hope you are understanding. Like that only if I draw another triangle like this in the third quadrant, what will happen? My theta will be this. This will be my right angle triangle. This will be my opposite side which is a negative x-axis because this is a negative x-axis, right? So here opposite side means sine theta. So sine theta will be negative. Then cosecant theta will be negative. And another thing, if I want to take the cos theta, then I will take the adjacent side which is again negative. So cos theta also will be negative. In third quadrant, what are the remaining things which will deal only with the opposite side and adjacent side? Because opposite side is negative, adjacent side is negative, they will get cancelled and they will become positive. So here only tan theta and its reciprocal cot theta will be positive. Okay. Similarly, if you do like this, another triangle if you draw here and this will be theta. Here in this situation, only cos theta and its reciprocal secant theta will be positive because only they will deal with adjacent side which is positive x-axis. Okay, I hope you are understanding. The reason why we have few trigonometric values positive in few quadrants is this. So this figure is important for you because in first quadrant all are positive, in second quadrant only sine and cosecant are positive, in third quadrant only tan and cot are positive, and in fourth quadrant only cos and secant are positive. You will have many mnemonics also to remember. Okay, I think I have given all this in the previous class, I think. So this is one concept of allied angles. Now let's talk about the complementary angles. What are complementary angles? You say that two angles are complementary if you add them and your answer is 90 degree. Then you say that they are complementary angles. I have a triangle like this. This is a right angle triangle. So if it is a right angle triangle and this is 90 degree and if this is theta, then obviously this angle should be 90 minus theta because sum of the angles of a triangle is 180 degree. In this 180 degree, 90 degree gone and theta gone. So the rest angle should be 90 minus theta, correct? So this is one triangle. Here, if I want sine 90 minus theta, see, let me write it like this. Here sine 90 minus theta is one angle. This is one angle. What is sine? Sine of any angle is opposite by adjacent, right? So what is opposite side for 90 minus theta? The opposite side is this, right? So it will be AB upon hypotenuse, which is AC. Okay. Now if I want cos theta, cos of some angle which is theta in this triangle, then it will be adjacent side upon hypotenuse. So if you carefully see, it is same, AB by AC. They are same for sine 90 minus theta and cos theta. That's the reason why we have this identity. Sine 90 minus theta is always equal to cos theta. Similarly, we have cos 90 minus theta is equal to sine theta. Similarly, we have tan 90 minus theta is equal to cot theta. Okay, like that you can go on do, and these are the reciprocals, right? So this is how you can derive the identities. See, all the trigonometric formulae and identities are derived. After derivation only, mathematicians have come to conclusion and they have brought up the list of the trigonometry formulae or identities. But what we are going to do in this class is we will just derive one identity, because our aim is to focus on examination, the multiple choice question paper pattern examination, and 2 questions are asked in trigonometry. Okay, so I will not go into much deeper by deriving each and every identity. I will give you idea about how the identity is derived. Like for example, I gave this one. Okay, so you have to assume that the rest one are also derived on same lines only. Okay, see, why I am deriving these identities means, if I tell you to just mug up or by heart the list, it is very tough. It is not easy to by heart the mathematical formula list just like that. But if you know how you have derived it, then things will become very much clear, and you will not have any need to by heart it also, because you know the logic behind how that formula came, right? That's the reason why I am trying to derive at least one equation or one formula or one identity from the list. Okay, so this though I think now it is clear for you why we always say that sine 90 minus theta is cos theta and cos 90 minus theta is sin theta. Okay. Similarly, we have a supplementary angles. Like what we told for complementary, we told that sum of the angles should be 90 degree. Like that only we have a sum of the angles is equal to 180 degree. So here also you can derive things like that only. See, if you want to find a sin theta and we are talking about 180 degree. So what you do, this is your 180 degree, right? Correct? So this is your 180 degree. If you want to say that there is one angle like this, and this is your theta and this is your right angle to triangle, then what will be the rest angle? It will be 180 minus theta, because the sum of the angles of a straight line is 180 degree. Correct? Now this sin theta will be equal to the opposite upon hypotenuse. Correct? So what will be the rest 180 minus theta? That will be equal to this theta. So that is the formula. Okay, like that only if you want to talk about cos theta, then you will have a minus sign outside. What is the reason? See, in first quadrant though all are positive, but in second quadrant only sin theta is positive, and 180 minus theta is falling in second quadrant. So here sin is positive, that's the reason why you have sin theta. But in second quadrant cos is negative. Correct? It is negative. So that's why you have minus cos theta. Again you will have cosecant theta positive, because it is positive in second quadrant. But secant theta is a reciprocal of cos theta. So that's why cos is negative, means secant also will be negative. Okay, and rest tan theta is also negative in second quadrant, so you will have negative, and cot is reciprocal and it is also negative. Correct? See, when we talk about 180 degree means we are talking only till second quadrant, like this. First quadrant, second quadrant. First quadrant ends with 90 degree, second quadrant ends with 180 degree, and here we have only sin theta is positive in both the quadrants. Sin theta means obviously even cosecant theta will be positive, because Sin theta is reciprocal of cosecant theta and all other angles will be negative. Okay, like that only if you move towards 270 degree, at that time here, if you come here, means if you write like this, sine of 270 minus theta, then obviously this will be equal to minus sine theta because sine is negative in 270 degree. I hope I am clear. Okay, you can do it for all other angles also. Okay, but you have to remember this list. I told you the derivation, the logic behind the formula. So using that logic, you should remember the entire list. Okay. Now let's come to the most important list of formulae, which is a sum and difference of angles or addition and subtraction of angles or trigonometric identities inside it. Okay. Now trigonometric identities involve the angles, and those angles are added or subtracted. Sine of alpha plus beta is equal to sine of alpha into cos beta plus cos of alpha into beta. See, it can be any angle. The symbol for angle can be theta, it can be alpha, it can be beta, it can be x, it can be y, it can be a, it can be b, it can be c, it can be d. Anything can be there. But anything which is there inside the bracket, that is your angle. Whatever it can be. Okay. Don't get worried with the symbols. Never get worried with the symbols. Okay. Even it can be gamma also. In fact, alpha, beta, gamma, theta, these are all Greek alphabets which are usually used as angles. Okay. Now first identity. It is sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. Like that only you have alpha minus beta. Like again you have for cos alpha plus beta, you have cos alpha minus beta, then tan alpha plus beta and tan alpha minus beta. Even these are all derived identities only. Okay, but these are very, very important identities, so you need to remember all these. Okay. Now let's talk about the trigonometric identities of opposite angles. Opposite angles. It is sine of minus theta is minus sine theta, cos of minus theta is cos theta, tan of minus theta is minus tan theta, cot of minus theta is minus cot theta, secant of minus theta is secant theta, cosecant of minus theta is minus cosecant theta. If you want, you can prove them also. Like for example, you use the previous identity. Sine of a minus b is equal to sine a cos b minus cos a sin b, and you take this sine of minus theta, the first identity. Okay. You can prove that it is equal to minus sine theta. This sine of minus theta is there, no, that you can write as 0 minus theta. Then you use this identity sine of, let this be a and let this be b. Okay, now use this formula sine a cos b minus cos a sin b. Okay, so it will be sine 0 cos b minus cos 0, actually it should be cos 0, yeah, it is cos 0, and then sine theta. Okay, now this will be equal to sine 0 is 0 and cos 0 is 1. Okay, you know the trigonometric tables, right? The trigonometric ratio values along with angles, right? I have told about this in the previous class. Anyway, I will tell in the present class also. Later I will tell. Okay. Anyway, so this, if you want to derive, no, you will understand when you substitute, this will become 0 because sine 0 is 0. Okay. And this will become 1 because cos 0 is 1. Okay. Anything multiplied by 0 will be 0 and minus 1 sin theta. Your answer will be minus sin theta. This is the identity. Okay. So like that only you can derive the other identities also. So these identities are known as identities of opposite angles. Another list of identities are double angle trigonometric identities. These are very famous and very important identities. Sin 2 theta is equal to 2 sin theta cos theta. Cos 2 theta is equal to cos square theta minus sin square theta is equal to again 2 cos square theta minus 1. This is equal to again 1 minus 2 sin square theta. Okay. And tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. Okay. Now using these identities, we have derived half angle identities also. It is sin theta by 2 is equal to plus or minus square root of 1 minus cos theta by 2. Cos theta by 2 is equal to plus or minus square root of 1 plus cos theta by 2. and tan theta by 2 is equal to plus or minus square root of 1 minus cos theta by 1 plus cos theta. You can also derive this. I will show you how to derive. Let us try to derive this first one, this one. For this, what we will do? We have three identities for cos 2 theta, right? We will take one. Cos 2 theta is equal to 2 cos square theta minus 1, you think. Okay. Now, if you want to take this as just theta, means you are making the angle half, right? So, you will write like this: cos theta is equal to 2 cos square theta by 2 minus 1, correct? Similarly, we have cos 2 theta is equal to 1 minus 2 sin square theta. So, if you take just theta here, means you take half of this angle, you will have 1 minus 2 sin square theta by 2, correct? Now, I can write this 1 minus 2 sin square theta in the left hand side, and I can write cos theta in the right hand side, right? Or I can write sin square theta is equal to cos theta minus 1. Here I have minus 2. If I remove the minus signs from both hand sides, I will have 2 sin square theta is equal to 1 minus cos theta. I am just inversing the signs. Or I will have sin square theta is equal to 1 minus cos theta. Or I will have upon 2, right? Then I will have a sin theta is equal to plus or minus square root of 1 minus cos theta by 2. Correct? So, I have theta by 2 here, right? I have not written it. So, this is sin theta by 2 is equal to plus or minus 1 minus cos theta by 2. This one. Okay? So, this is how you can derive it. You can derive other identities also. Okay? But now, right now, our aim is that we should remember this list of identities. Okay? Next, we will talk about trigonometric identities of products. Sin A, sin B is equal to cos A minus B minus cos A plus B whole divided by 2. Or sin A into cos B is sin A plus B plus sin A minus B whole divided by 2. Or cos A cos B is cos A plus B plus cos A minus B whole divided by 2. We can also prove it. Like for example, if you want to prove this identity, the first one, this identity, if you want to prove, what we do? You take that famous formula of addition. Sin A plus B is equal to sin A cos B plus cos A sin B. Then you take another formula for subtraction. Sin A minus B is equal to sin A cos B minus cos A sin B. Then you add these vertically. If you add them vertically, you will get sin A plus B plus sin A minus B in the left hand side. In the right hand side, you will get these things will be cancelled. So you will add this and this, right? 2 sin A cos B will be there. If you send this 2 in the right hand side, you will get this formula. Sin A cos B is equal to half into sin A plus B plus sin A minus B. Okay. So this is how you have derived these identities. So I will stop the class now. Actually, I thought that I will be finishing much of the portion in this class. But then explaining is taking lot of time. So I have decided that I will continue this part in part 3. There I will discuss more identities, and also I will discuss all the planned multiple choice questions, which will be very, very important, and they are expected questions. Okay. So meet you in the part 3 class of trigonometry, and then in part 4 I will discuss heights and distances. Okay. So okay friends, I really hope that this class helps you. Believe me, this classes of trigonometry which I am taking, no, totally I have planned for 4 classes. No, all these 4 classes are very, very important classes. And once you attend these 4 classes, means still 2 classes I have not posted. I'll post those 2 classes also. Once I post, no, all the 4 parts of trigonometry are more than enough for your HSTR examination. You don't need to go for any other source, and you don't even need to practice more problems after attending and making notes of the 4 classes of trigonometry. Okay. So please do subscribe to my channel if you have not subscribed, and if you like my work, please do like this video and also share among other HSTR aspirants. And also I have a Telegram channel. The link will be given in the description below this video. Please do join the Telegram channel for more future updates and discussions based on physics and mathematics for all the teacher recruitment examinations. And also I have a paid classes for HSTR PM course. If you are interested, then you will find the details in the comment section below this video, or you can also mail me. You will find the email ID also in the comment section. Okay, thank you, all the best, bye.